In this video, we're going to look at how to automate and automatically generate some repetitive tasks, such as the one that we see on the screen here. So on the screen, you can see that we would like to generate the numbers 0 to 5 really quickly and just have them generate in a list. Something like this, if you did with the tools that you already have, you could probably write 6 statements doing a cout, and you could say, well, cout 0, cout 1, cout 2, and so on and so forth, which is okay if you have a limited number of couts to do. However, if you're working with numbers in the thousands or the millions, and you want to generate a set of numbers or multiply a set of numbers or do some math over and over again repeatedly, it becomes very tedious to write a line of code for each piece that you want to generate. What makes more sense is to make a loop, what is called a loop, and put your code inside the loop so that every time the loop runs, it executes the command over and over again. That's what I'm going to show you how to do in this video. So let's start with our first example. Let's say in our first example, we want to generate the numbers 0 to 1. This is what we need to do conceptually. So this is the kind of concept you need to put in the back of your mind while you're writing code. The first thing you need to tell the program is you ask it to set up a counter. Counters can be named whatever you like, but there's a sort of a convention in C++ that counters tend to be called the variable I. So the first thing you tell the program is, okay, I want you to start a variable, which is a counter. I'm going to call it I, and I want you to start it at 0. The next thing you need to tell the program is when the variable I should stop, when the counting should stop. Since we want to stop at 5, I should only go as far as 5. It should not exceed 5. And the third thing you need to tell the program is by what amount I should increase or decrease or be divided by, or whatever it might be. In this case, we just want to add 1 to I, so we need to tell it to add 1 each time. So from 0 it becomes 1, from 1 it becomes 2, from 2, 3, and so on and so forth. So these are the 3 pieces of information you need to give to your program to generate a loop. This particular loop is called a for loop because it runs for a specific amount of time. There are other types of loops which we will cover later in later videos. When you set up your loop, you also have to tell it what it needs to do every time it counts. In this case, every time it counts a number, such as when it counts 0, it needs to print whatever the value of I is at that point in time. And as you can see at this line, I is 0, so it'll print 0. Then you need to update I, and then once again you say, okay, now print it again. So inside the loop you write print I, and now since the value of I has been updated to 1, it'll print 1. Then in the background it'll update again, because that's what you designed the for loop to do. Then it'll print again. So it zigzags between counting, printing, counting, printing. To write this in C++, what you would do is you would start off in your main program, and this is how you design a C++ for loop. You write the word for, which means I'm going to set up a for loop, and then in parentheses you make your variable int, so you say I is an integer which begins at 0. Then you tell it to make sure to check that I is always less than or equal to 5, which means keep going as long as I is less than 5. So if it's a 3 or a 4, keep going. But stop once it becomes equal to 5. So don't make I 6. And then you tell it how much to update or increment, which means increase I. And that you write as I++. I++ simply means add 1 to I. Whatever the current value of I is, add 1 to it. So what we've done in this line of code is we've set up our for loop. We have told the program how to count and when to start, when to stop, how frequently to update the counter. What we haven't told it is what to do every time it counts. To tell it what to do every time it counts, we're going to have to put in a new set of curly braces, And it's inside these curly braces that we tell it what to do. And what we want it to do is very simple. We want it to see out or print out whatever the value of I is, and also put a line, end the line and go to a new line, so that when it's ready to print again, it's printing on a new line. So I'm going to do \n there, and I'm going to end the command with a semicolon. So now if you run the program, it basically starts counting at 0, goes all the way to 5, updates in ones, and stops at 5. And it knows that every time that it does this, it needs to print. Now, the thing to remember here is this counting will happen in the background whether the numbers are printed or not. This is a common confusion. The counting happens whether we ask it to print it or not. We happen to have asked the program to print what it's counting, so it's printing it on the screen. But these numbers are not printed on the screen unless you ask the program to print it on the screen. So for example here, if I said keep counting and kept the counters exactly the same, except I said every time you count, whatever the value of I is, don't just print the value of I, print the value of I times 10. What do you think will happen? Think about it for a minute. The first time the value of I will be 0. So the first printout should say 0 times 10, which would be 0. Then the value of I would be updated and become 1. 1 times 10, 10. Next line, 2 times 10, 20. Let's try it. And there you go. So it hasn't changed how it's counting in the background because we have not changed the for loop. But what it has done is it has changed what it prints, because we asked it not just to print the value of I, but the value of I times 10. Well, what if you wanted to generate a set of numbers by changing the value of the counter? So let's say we wanted our program to count from 100 to 200. Could we do that? There are a number of ways you can do that, but the easiest way is to just change what it counts. So all you would do is you would go into the program and tell it to start counting from 100. Tell it to stop when it hits 200. And if you want to count in ones, you leave that last piece the way it is. And then you say, print out whatever the value is at that point in time. And then go ahead and run the program. And as you can see, it has printed all the way down to 200. And if you scroll to the top, it's gone all the way down from 100 to 200. What if you wanted it to count in fives? Well, instead of, you could keep the exact same numbers for beginning and end, but let's say you wanted it to count in fives or in 20s. What you would say is you would update I by, you would say make I equal to I plus 20. Which means instead of updating I by 1 every time, you update it by 20s. And now let's go ahead and run it. And as you can see, it went from 100 to 120, 140, 160, 180, and 200. What if you wanted it to count backwards? Well, if you wanted it to count backwards, you, instead of in ones, instead of saying I plus plus, you would say I minus minus, which means take away 1 from the value of I. But obviously you cannot get from 100 to 200 by counting backwards in ones. So we need to flip this. Let's say we want to count from 10 to 0 to 1. And we want to count backwards. We would ask it to start at 10. We would ask it to stop when it hits 1 and to count in negative ones. If we go ahead and run this. Okay, so that's not running, so that means there's an error there. So let's go back and look at our code and see what the error might be. So we've said start int I at 10. Keep going as long as I is, oh, there's the error. The program currently says as long as I is less than 1. Well, that's not going to run, because if the program is starting at 10 and you want it to run from that value, 10 is greater than 1, not less than 1. So that's needs to change to greater than. Now let's go ahead and run it. And there we go. Now, sometimes you will have questions that ask you to get the user to input the number to which they would want to count, or the number to which you want to do a particular mathematical calculation. So let's say the user says, your program should say, how far would you like me to count? And the user says 1,000. Then your program has to count from 0 or 1 to up to 1,000. You have to create a box, a variable, to capture that number that the user wants and make that part of your for loop. So this number, where to stop, this one, if it's not known, that cannot be a particular number because you don't know how far the user wants you to count. So that has to be a variable. So the way you would do that is, you'd see out a message and you would say, how far would you like me to count? And you can do a end the command there. And then you would create a variable that would store the answer. Let's call that num. And you would read in. You would read in your value into num. And now in your program, depending on how you want your program to count, let's say you want it to count from 1, you say start I at 1, keep going as long as I is less than or equal to whatever num the user has said, and then count forwards in ones. So now the program will start with 1. It'll keep checking to make sure it doesn't exceed whatever number the user has put in, and it'll count forward in ones. So now if I run this program and I want to count up to 20, there you go. It started at 1 and it kept checking to make sure it didn't exceed 20, and it has printed all the way up to 20. So as you can see, if you get the basic structure of how a for loop works, if you remember where to start it, which is this one, where to end it, and how frequently to update it, and you figure out what to ask it to do, then you can solve a lot of problems with a for loop. What if your program wants you to check, read in several numbers and then check something with them? If you want to read in several numbers, you would get the program to continue to start its counting, but every time it counts, you would get it to read a number. So I'm going to move the read in into the for loop here. Okay, so let's say we want the program to read in 5 numbers, and my message is going to say something like, please enter 5 numbers separated by spaces. So the program knows every time it encounters a space that there's a new number. And then I want my program to read in. Now what it's doing is, in every loop, it's reading in one number, the first number that the user has typed in. And let's say I want it to multiply that number by 5 and print it out. I would say num, see out num times 5. So just by looking at the structure of this loop, you can tell what it's doing. It's counting from 1 to, let's say I only want this to run 5 times. It's counting from 1 to 5, so it's running 5 times. Every time it runs, it's reading in one number from what the user inputted. Then it's taking that number, multiplying it by 5, and printing it out. So the thing to remember here is we're asking the user to enter 5 numbers in one go, but because those numbers are separated by spaces, the program only reads one number every loop. It just reads that first number, does what it's supposed to do, then goes back and reads the second number and does what it's supposed to do. So now if we go ahead and run it, and I enter the numbers 1, 10, 6, 3, and 8, and I press enter, there is my result, all multiplied by 5.